Hello and welcome to the Unit 8, number 8. Here we're solving a system of inequalities, and what that means is we, instead of having two or more equations, we have two or more inequalities, and solving them is a little bit different. When we're done, we're not going to, in general at least, we're not going to have x equals this number, y equals this number. We're going to have a whole set of points that really there's no good way to show other than to show them graphically. So what we're going to do is we're going to graph each one of these inequalities separately, and then we're going to determine where on this plane we would be, where both of the inequalities will be true. So we'll do them one at a time. I'll start with the first one, and the first one I'll be doing in blue. Alright, so the equation is 3x plus 2y is less than or equal to 10. I, of course, meant to say inequality, not equation there. So somehow or another we need to graph this line. And so you can sort of think of this for the moment as an equal sign. And we're going to graph the line where it's an equal sign, and then we're going to do some shading at the end to account for the fact that it's an inequality and not an equals sign here. So anyway, in order to graph this, since I know 3 doesn't go nicely into 10, I don't think I'm going to try to use the intercept method. Instead, I'm going to try to isolate this y variable. So I'm going to subtract 3x on both sides, and then I'll have 2y is less than or equal to 10 minus 3x, and then I'll divide by 2. So I will end up with y is less than or equal to 10 over 2 is 5 minus 3 halves x. Alright, so I've got it in slope-intercept form now. The y-intercept is going to be 5, and the slope is going to be negative 3 over 2. So down 3 to the right 2. So let me make some points in this direction. 1, 2. Alright, and then I'm going to make just 1 or 2 the other way as well. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Alright. Now, this line that goes through these points represents all of the points where y is equal to 5 minus 3 halves x. But what we're looking for here is where are all the points where y is less than 5 minus 3 halves x. And there's sort of two ways to think of this, and I'll try to explain both ways here. One way is you just test a point. It's either going to be all the points above the line or all the points below the line satisfy the inequality. So you can pick any point you want. People often test the point 0, 0. What we're going to do is we're going to substitute 0 in for x and 0 into y into this inequality, and we're going to see whether or not it comes out to be true. Incidentally, it might even be easier to check that 0, 0 point up here, because 3 times 0 is 0, and 2 times 0 is 0, so this whole side just becomes 0, and then this whole 0 is supposed to be less than or equal to 10. Now, is that true? Is 0, in fact, less than or equal to 10? Yes, it is. So, we tested this point right here, 0, 0, and we found out that it does work in the inequality. It is true in the inequality. And that means that all of these points down here below that blue line must make the inequality true. Now, just for the heck of it, let's test one of these points on the other side of the line and make sure that it really doesn't work. So I'm going to test this point right here. I'm going to test 4, 2. Alright, and again, I mean, you can use this form of the equation or this form of the equation. It doesn't matter. I'm just going to use the top one. So I'm going to do 3 times 4 plus 2 times 2. And the question is, will it be less than or equal to 10? Well, let's see what happens. This is 12 plus 4, and that's supposed to be less than or equal to 10. Clearly that's not true. This is false. So the points on this side of the line will make the inequality false. So points over here are not part of the solution. The points on this side of the line are part of the solution. And the way we show that all of the points over here are part of the solution is we somehow shade this portion of the graph. Now, some people just do it by sort of coloring in like that. I actually prefer to kind of make stripes off of the line. Okay, so that's all the places where that first inequality is true, is anywhere that's shaded in the blue. Now I'll handle the second inequality. And again, I think I'm going to try to get that y by itself. So I have negative 7y is greater than negative 28 minus 3x. So I'm trying to get this y by itself. So clearly I'm going to have to divide both sides by negative 7. And something that I think a lot of people are going to forget to do is whenever you divide both sides of an inequality by a negative number, you have to reverse the inequality sign. So when I should really change it right now. Let me come down and write things a little more clearly. It used to be y is greater than, now I'm making it y is less than, negative 28 divided by negative 7 is 4, and negative 3 over negative 7 is positive 3. So I'm sure if you look at the solving section, you'll be able to get more information on why we had to flip that inequality sign around. But anytime you're dividing or multiplying both sides of an inequality by a negative, you have to switch the inequality. Okay, so let's graph this line. Y-intercept is 4, and the slope is 3/7. So we go up 3, 1, 2, 3, and over 7. 7, so that goes here, and I'll go the other way, down 3, and to the left 7. It seems like those are the only points I'm probably going to fit on this graph. Now, one mistake that a lot of people make right now is they just go ahead and they draw the line through those points, and here's why that's a mistake. For starters, I didn't do a very good job of getting it through the points. But the other reason is that this inequality, or I guess I should reference it down here, this inequality is not or equal to. And remember what this line through those points represents. That line represents the points where y is exactly equal to 4 plus 3/7 x. Well, we don't want to count those points. We only want to count the point that where y is less than 4 plus 3/7 x. So one thing is we don't draw a solid line here. We draw a dotted line or a dashed line through those points. And you'll notice in the first problem, or sorry, in the first equation, that the first inequality, that really wasn't an issue because it had the or equal to sign. So there we drew a solid line. But with the red one, we're drawing a dashed line. And again, somehow or another, we need to figure out which side of the red line do I need to shade. The first time through, we did it by testing a point. We actually tested 2 points just to be sure. This time, I'll show you another way to think of it, and that is, if you read this inequality, it says y is less than some stuff. Okay, well, in what direction does y get less than? Now, y only goes in 2 directions, right? Y goes up and down, and the way it gets less is when it goes down. So if we know y has to be less than this, we know that from this dashed line, we must be shading downwards from that line. You can still do this by testing a point, that's fine, but I thought I'd show you another way. Alright, and so now this drawing is a little bit messy, but you'll notice there are sort of 4 sections on the graph right now. There's this section in the top, all in here, where nothing is shaded. There's this region over here where only the blue is being shaded. There's this region over here where only the red is being shaded. And the one we actually care about, the one that is the solution to this inequality, is this region down here where both the red and the blue are being shaded. Remember, what it means to solve a system is to find the values that make both, or I should say all, of the, in this case, inequalities true. And so we're looking for the place where both inequalities are being shaded, and that is that section sort of down on the bottom that I've colored in with the green highlighter. So that is how you solve a system of inequalities. You graph each inequality separately and find out which way it would be shaded, and your final solution is the region where both inequalities are being shaded.